Okay, right, welcome to, this is C1, okay, going through the Monday, the 19th of May, 2014 paper. Okay, so let's just get ourselves to C1. Well, obviously, we've already been through the rest of it, so let's just get started. This question is about paints. A company wants to make a mug. The picture on the mug will appear when a hot drink is poured into it. So a hot drink goes in, you can see that's cold, and that is hot. Okay, what type of pigment should the company use? Well, what kind of pigment would change colour with temperature from hot to cold is obviously thermochromic. Remember, the word thermo means temperature or heat, and chromic obviously means colour, so the answer is thermochromic. Okay, now look at the pie chart showing the ingredients of three kinds of paint. You can see that this one's 40% solvent, 20% pigment, 20 polymer and ingredients. This one's more 50% binding medium, 50%, 25% pigment, etc. This one's 40 binding medium, 30 solvent. Which paint would you expect to spread most easily on a wall? Now, what bit of the paint helps things spread? Well, it's obviously a solvent. Solvent helps paint spread. So which one has the most solvent? This one has 30, this one has 10, this one has 40. So it would be A, wouldn't it? Explain your choice. A has the most solvent in. I'd probably say to first begin with. I'd say it has 40% solvent, so it has the most solvent out of A, B and C, and solvents help make the paint spread, I'd guess. Let's have a look at what it's saying. Okay, thermochromic, idea of highest percentage of solvent, and that was it. That was actually a lot more easy than we thought. So A, so you get 1 mark for saying A, and the second mark for saying that it contains most solvent and it helps allows it to spread. Or you didn't have to say that, really. Just idea of the greatest percentage of solvent. So that's actually much easier. Moving on to the next question. This question is about fuels. Michelle investigates 2 fuels, ethanol and butanol. The diagram shows the apparatus she uses. You can see that it's a copper can with a bit of 100 grams of water in it with a thermometer. And there is a spirit burner with a liquid fuel. Ethanol burns in oxygen, carbon dioxide and water is made. Write a word equation for this reaction. Guys, this could not be easier. You know, when you tell you something's happening and they want it in a word equation, all they want to say is ethanol. Okay, all they want you to do is put it in a word equation. So ethanol burns in oxygen. So it must be ethanol plus oxygen. And that was telling you carbon dioxide and water is made. So that's the products. So you do ethanol plus oxygen, which are the products. Then you would draw an arrow, and then it would be carbon dioxide and water. And this is basically, it should show you in the mock scheme what that actually looks like. There you go. Ethanol plus oxygen gives you carbon dioxide and water. Again, guys, that couldn't be easier. Okay. Michelle notices that butanol burns with a yellow flame. A black solid forms on the outside of the copper can. What is the name of the black solid? Well, that must be soot. Okay, or you can say it's carbon. Yeah, so soot or carbon. There you go. Because we know, because it's a yellow flame, it's giving you a clue, so it must be incomplete combustion. Michelle thinks incomplete combustion is happening, just like we just said. Write about 2 disadvantages of incomplete combustion. Well, that's easy, guys. You know incomplete combustion makes carbon monoxide, okay, and that is poisonous. That's one disadvantage. And number 2 is incomplete combustion. So it's obviously not burning all the fuel, so it's not going to be releasing as much energy, is it? So let's have a look. Soot produced, less energy, like we just said, poisonous carbon monoxide made. Easy peasy, 2 of the things that we've just said. Okay, so that is that. Michelle measures well, I didn't say A, but I'm just saying the mass of the fuel burnt, the temperature of the water at the start and the end of the temperature. You can see that fuel, ethanol, butanol, and that's the temperature of ethanol, 25 at the start, 45 at the end. And mass of fuel burnt, 0.5 grams. Cost of fuel burned in pence, cost them a pence. Okay, butanol starts at 20, finishes at 40, uses 1 gram to do it, and it costs 4p. Michelle thinks that butanol is a better fuel for heating the water. Is she right? Use information to help you. Well, first thing I'd look at is the temperature change. 25 to 45, that's a 20 degree temperature change. Butanol, 20 to 40. So they both give a temperature difference of 20 degrees. So that doesn't help. So they both give. So I'd probably write both ethanol and butanol give the same temperature difference. Now, which one is better? well, first of all, ethanol only uses half a gram, okay, whereas butanol uses a whole gram to do it, so it uses half the amount of fuel. So ethanol is the better fuel, I'd say, from that reason alone. Second one, cost of fuel, 1p to 4p. So butanol is 4p and ethanol is 1p. So you could rate that they both give the same temperature difference. Ethanol is the better fuel. So is she right? No. Ethanol uses less fuel and it's cheaper as well. Yeah. Let's have a look. Yeah, no, like we just said, both fuel gives the same temperature rise for 1 mark, but smaller mass of ethanol and the cost for ethanol is less. Okay, like we've just said. Let's have a look at the next question. Harry is a mountain climber. He wants to buy a new anorak. Okay, and that's the anorak right there, like that jacket that goes on top. Look at the table, it gives information about 3 materials. Material, cotton, is it waterproof? No. Is it sweat absorbed? Absorbed. Is it breathable? No. Nylon, is it waterproof? Yes. Is sweat absorbed? Not absorbed. And is it breathable? No. Gore-Tex. Obviously we know Gore-Tex is breathable, and we know that sweat escapes through the material, which makes it breathable. Yeah? Which is why it says yes. Which material is most suitable for an anorak? Explain your choice. I'd go with Gore-Tex. Gore-Tex is the most anorak because it is not only waterproof, but it is also breathable. Is that really a question? That's so easy. Let's have a look. Gore-Tex. Idea that it's waterproof and breathable. Oh, well, there you go. It was really that easy. Make sure you should have put both of those things down, why Gore-Tex is better. And again, we know Gore-Tex is breathable and waterproof, well, whereas nylon is not breathable, but it is waterproof, yeah, so it isn't as good. Gore-Tex is a material made from a non-biodegradable polymer. What is meant by non-biodegradable? Well, non-biodegradable means it can't be decayed by bacteria, yeah, it can't be decomposed, yeah, it will not decay, cannot be decomposed by bacterial action. Yeah, allow, does not rot, will not break down. Okay. Now, write 2 ways in that non-biodegradable polymers can be disposed for. Guys, this is really easy. We've talked about this a million times. There's 3 ways that polymers, non-biodegradable polymers can be disposed of. 1 is a landfill site. 2 is burning them. And 3 is recycling. Okay, and it should give you those options: idea of a landfill site, burying in, idea of burning, recycling, or cracking. Okay, I don't know about that cracking one, but those are the 3 ones that we've already talked about, okay, in lessons. Right, this question is about carbon compounds. Look at the displayed formula of the compounds. You can see the displayed which one is a hydrocarbon. Well, guys, we know a hydrocarbon is one that contains carbon and hydrogen. So let's have a look. Carbon and hydrogen? Nope, contains bromine. Carbon and hydrogen? Nope, contains oxygen. Carbon and hydrogen? Yes, carbon and hydrogen, nothing else. And this one obviously contains chlorine. So, which one is a hydrocarbon? Compound C. Look at the displayed formula of compound B. Let's have a look right there. Complete the table to show the number of type of each atom in compound B. God, this is easy. Number of carbon atoms. 1, 2. Okay, thank you. Hydrogen atoms. 1, 2, 3, 4. Again, easy. O. 2. Yeah, God, that's really easy. I was expecting that to be a bit more complicated than that. Right, which compound will decolorize bromine? Right, decolorize bromine, it is going to be compound C. Now, guys, remember when we looked at if you watch my revision videos, I showed you a video of bromine water, and when you pump an unsaturated compound in it, anything with a double bond, it makes it go from an orange colour to clear. Okay, if you don't know any of these points, watch my revision video for C1 again, guys. I think these questions have been very easy so far. Compound C is a molecular formula, C2H4. Compound C reacts with hydrogen H2. Look at the simple equation. C2H4 plus hydrogen gives you C2H6. Write down the formula of each reactant in this reaction. Guys, reactants are the things before the arrow. They're the things that you react together. So you could have just written C2H4, or you could have just written H2, sorry. If this question was slightly different and it says write down the formula of a product in this reaction, well, that's the product, guys, C2H6. Yeah, so these are the reactants, C2H4 and H2, and that is the product. Right, 6-mark question. Here we go, how exciting. Right, look at this displayed formula of propene. Okay, you can see that it has three carbon atoms and a double bond, which makes it propene. Okay, propene molecules can react together to make a polymer. Write about what happens when polymer molecules react together in your idea. Give the name of the polymer made and the conditions needed. Oh God, this is so easy. Okay, you can say first of all that this compound is a monomer and it can be joined together in a process called polymerization. And that involves joining the monomers together to make a polymer. And you could probably say that the name of this, okay, if the monomer is called propene, you can say that the polymer is going to be called polypropene. God, that is so easy. Okay, the conditions, you know the conditions for polymerization. You can also say the conditions for polymerization is high pressure and a catalyst. Okay, now if I were you, just to make this a little bit clearer, I'd probably draw that. I'd probably draw that as a monomer, and I'd probably draw the polymer with that, without the double bond, and a bracket on the outside with a little N on the side of it. Okay, let's have a look at what the mark scheme says. Let's see what the mark scheme tells us. Okay, right, now, number 1 describes polymerization of propene. Gives the name of the polymer made. Okay, I think we've done that. By the way, that's what I was talking about. No, that's not what it should be. Yeah, it should be with the CH3. I don't know what the mistake they made. Let's just go straight through a level. Okay, level 2. Describes polymerization of propene, gives the name of the polymer, or names the polymer at least one condition, describes polymerization reaction, and gives at least one condition. Oh, God. So if you only named one of those, either high pressure or a catalyst, then you'd get 1 mark. And if you gave the name of the product, which is polypropene, then you'd be in level 2. For level 3, which is what my answer was, describes a polymerization reaction of propene, gives the conditions needed, which were high pressure and a catalyst, gives the name of the polymer made, which was polypropene, and that was it. And that is that easy. And that would be 6 marks. Guys, that was easy. Easy. Okay, so that is the C1, guys. Okay, in the next section, I'm obviously going to be going through the P1. Okay, right, hope that made sense. And make sure, guys, I'm going to reiterate this, just to make sure that you know that I want you to do the past papers first. And then I want you to watch these videos and see what you can learn from it. Okay, I'm out.